Alrighty, in today's video, we're going to look at chapter 14.1. It's going to be Introductions to Rational Expressions. Rational is just a fancy word of saying fractions. So we're going to deal with equations that deal with fractions. All right, so here we go. So number one, the questions are going to ask you determine which values of the variable, if any, will make the expression undefined. So we're going to look at this right here. So I guess let me look for values that make the expression undefined. And if you recall, when we were talking about graphing, I think that was chapter 10, something that was undefined was when you had a fraction that was some number over zero. We could not have zero on the bottom of a fraction. So when you are presented with expressions that look like this, 9 over 5x minus 1, all you're going to do is take the denominator and set it equal to 0 and solve it just like we did in chapter 13. So now what I'm going to do is I'm going to do the opposite, subtracting 1. So I'm going to add 1. So that gives me 1. And then I'll divide by 5 because that's what the opposite of multiplication is. So then x equals 1/5. So that is the value that would make this undefined. X equals 1/5. All right, let's look at another one. Let's look at part B. We have x squared minus 25 divided by x squared minus 7x plus 12. I do not care what's going on the bottom or the top. I only care what's going on the bottom. So therefore, I take the x squared minus 7x plus 12 and I set it equal to 0. So now I'm ready to do my t-chart. So what multiplies to my c, which is 12? What adds to my b, which is negative 7? I want to multiply to a positive, add to a negative. So that tells me both of them are going to be negative. So it's going to be -1, -12. That gives me -13. So that I do -2, -6. That gives me -8. Then I'll do -3 and -4. And that gives me my -7. So therefore I get x minus 3, x minus 4. And then I would set those factors equal to 0. So x minus 3 equals 0. X minus 4 equals 0. Opposite of subtracting 3 is adding 3. So I get x equals 3. Opposite of subtracting 4 is adding 4. So I get x equals 4. And that's it. So you figured out what x basically cannot be, which will make this function undefined. Let's look at one more. Let's look at C. Let's look at x plus 8 over x squared plus 16. So again, I only care about this. So x squared plus 16 equals 0. I cannot factor it. So therefore, I'm just going to try to isolate my x. So I'm going to subtract 16. And then I get x squared equals -16. And we talked about to get rid of a square, we're going to take the square root. The issue we come up with is the square root of a negative is not a real answer. So if you cannot solve for x, that would mean there are no values. Or I guess in this case, there are no real numbers that would make this undefined. All right. Those are all the different situations there. So let's look at number 2. The next I have a question you're going to be asked is find the value of each rational expression for the given value of the variable. So we're going to evaluate. So you are presented with -x over x squared minus 5. And we want to know what is the answer when x equals 4. So remember, when we evaluate, we're going to plug in for all my x's. So this becomes negative. My x gets replaced with a 4. I use parentheses when I substitute. This x gets replaced with a 4. Square on the outside of the parentheses, minus 5. So now I evaluate it. Negative times 4 is just negative 4. 4 squared is 16 minus 5. Nothing else can happen on the top. And then 16 minus 5 gives me 11. So my answer there would be negative 4 over 11. Let's do another one. So get B. This is z plus 1 over z squared plus 4. And I want to know what the value is when z equals negative 2. So I'm going to plug it in. Again, replacing all of my z's with this value. So this gives me negative 2 in parentheses plus 1. And this gives me negative 2 squared plus 4. Now I'm going to evaluate. Negative 2 plus 1 is negative 1. Negative 2 squared means negative 2 times negative 2, so that come out to positive 4. If you're using your calculator, make sure you put it in parentheses. Plus 4. 4 plus 4 is 8, so therefore my answer would be negative 1/8. So that's the next thing you have to do on your homeworks. And then we're going to kind of put a lot of this together. So number 3, you're asked to simplify the expression. So here we go. We get 2x minus 6 divided by 5x minus 15. So this is how I teach my kiddos. When you're simplifying rational expressions, there's 3 steps. 1, factor. 2, cancel. 3, write. So what this means is I'm going to factor both the top and the bottom. So I notice on the top, I look for my greatest common factor. That's always my number 1 question. And I see that 2 does go into 6. So 2 would be my greatest common factor. So then if I divide each one of these by 2, 2x divided by 2 would just give me x. 6 divided by 2 would give me 3. Then I do the same thing over here. 5 does go into 15, so 5 is my greatest common factor. So I divide them both by 5. 5x divided by 5 would just be x. 15 divided by 5 would be 3. So that's the first step. I factored. 2, I'm going to cancel anything that looks the same. So I see that this x minus 3 looks like this x minus 3, so I can cancel them. And then now my last step, I'm going to write what's left. I have a 2 left on top and a 5 left on bottom. So that would be your answer. Now, the second part of this, that was to simplify, but then it also said state any restrictions. And that's when I'm going to take just the bottom. Now, you can start here and refactor, or you can do your work that you did here with the factoring already. So I'm going to take that, my 5x minus 3, and I'm going to set it equal to 0. So since it's already factored, I can just set my factors equal to 0. 5 does not equal 0, so that I can discard that. So then all I got to do is just add 3. So x equals 3 would be my restriction. So the way you want to write it in your homework is x cannot equal 3. So this is does not equal. So that cannot equal 3. Alrighty, let's look at some more situations. This next one is x squared minus x minus 20 divided by x squared minus 25. So I'm going to use my t-chart on this one. Let's see, so I guess I'll do my work here. I'll put t-chart here. I want to multiply to a negative 20 and add, that's what my c is, I want to add to my b, which is -1. Remember, there's always an imaginary 1 there. And so then I multiply to a negative, but I want to add to a negative, so that tells me a bigger number better be negative. So I try 1 and -20, but I get -19. 2 and -10, but I get -8. 3 doesn't go into it. 4 and -5, there's my -1 right there. So then I rewrite this. I'll put it, I guess, right here. I'll say that this is x plus 4 and x minus 5. Now I got to do the same thing to the bottom. So I need to figure out what multiplies to -25. I'm missing that middle term, so I'll just say it's equal to 0. So I got to come up with two things that multiply -25 but add up to 0. So if it's a negative that I multiplied, it'll be opposite sides. And since I'm adding to a 0, that tells me that both values are actually going to be the same. So that one's a positive, one's a negative, so they would cancel each other out. So with that said, I can be like, all right, well, the two numbers that multiply 25 that are exactly the same would be 5 and 5. That's going to make one of them negative. So therefore, I then get x plus 5 and x minus 5. So that's first step. Everything is factored. Step 2, now I'm going to cancel. So I cancel my x minus 5s. Step 3, I'm going to write what's left. I cannot cancel these x's because they're attached to a plus 5 and a plus 4, so they're not the exact same. So therefore, my answer would be x plus 4 divided by x plus 5. Then I have to state the restriction. So then I'm going to take my factored denominator. I'm not going to look at this one. I'm going to look at this one so that I can go, all right, well, x plus 5 and x minus 5 equals 0. I do include, I probably forgot to say that up here, but I do include things that got canceled because it's still there. It's just graphically, one day you'll see that it ends up being a whole. That's a different discussion for a different day. So this is x plus 5 equals 0, and this is x minus 5 equals 0. So I'm going to subtract 5 on both sides. So this gives me x equals -5. I'll add 5 on both sides. So I get x equals 5. But in this case, this is restriction, so x cannot equal -5 and x cannot equal 5. So those will be your restrictions. All right, let's look at another one. Let's look at x minus 5 over 5 minus x. Now in this situation, if they almost look exactly the same, they're just in the opposite order, what we can do is we can actually factor out a negative. So I'm actually going to factor out a -1. And when you factor out a -1, what it does, it switches their places. So this now becomes x minus 5. So if I was to go -1 times x, it would go back to -x, and -1 times -5 would go back to a +5. So with that, I can then say, oh, my x minus 5s would cancel. Another thing to note is if everything gets canceled on top, there is still a 1 left. And in this case, a -1 left on bottom. And then 1 divided by -1 is -1. So that would be your simplified answer. Now to find your restrictions, again, you can take either one of these. I like to take the factored version. So -1, x minus 5 equals 0. Set them equal to 0. So -1 equals 0. X minus 5 equals 0. -1 does not equal 0, so that goes away. And then all I got to do is just add 5. So I find out that x cannot equal 5. All right, and that's pretty much it for 14.1. So a lot to absorb there. As you come up with questions, feel free to email me and I'll get back to you as soon as I can. Other than that, I'll see you in the next video. Bye for now.